Hey guys, welcome to today's video. Today we're going to be solving Leetcode 118. That's Pascal's triangle. We're told that we're given an integer num rows and we need to return the first num rows of Pascal's triangle. So in Pascal's triangle, each number is the sum of the two numbers directly above it, as shown in this little diagram over here. So for example, the first row has no parent nodes, so it'll just be 1. And then the second row, although it has one parent node, it doesn't have a right or left parent node, so each node is also just going to be 1. And the third row, well, 1, there is a right parent node for the first node, but not a left one, so that's just going to be 1. But in the center, well, the two numbers directly above it are 1 plus 1, which is going to be equal to 2. And then again here, 1 plus nothing will just be 1. And we basically keep on going, so on and so forth, until we reach num rows, and at that point we just simply return our new triangle. So if we look at how we're going to solve this problem, we can see we've got center nodes, and we've got nodes on the outside. Well, the nodes in the center have both parent nodes. So in this case, 1 and 1, which is going to be equal to 2. Over here, 1 and 2, which is going to be equal to 3. 3 and 3, which is going to be equal to what 3 and 3 is, which is 6. 3 and 1 over here, which will be equal to 4. But the numbers on either side of the triangle, right on the edge, are not going to have any numbers on the left. So for example, 1 here has 1, but there's nothing on the left, so it simply is going to be equal to 1. So how can we solve this problem? Well, we can use a little hack, and that's by pretending that there's a 0 at the beginning and end of each row. And this makes our problem a lot easier to solve. So 0 plus 1, well, that's just 1. 1 plus 0, again. And the same is going to be for the second row. 0 plus 1, well, that's just going to be equal to 1. 1 plus 1 equal to 2, and 1 plus 0 is equal to 1. So if we were to put this in an array form, well, let's have 1, 2, and 1. And we need to add zeros at the beginning and at the end of our row. So 0 plus 1, well, that's just equal to 1. 1 plus 2, that's equal to 3. 2 plus 1, that's also equal to 3. And 1 plus 0 is equal to 1. So that's our final array. And this is the approach that we're going to be using to solve this problem. Okay, so hopping into the code, we need to start off with a base row. So we'll create a result array, and we'll have our base node or our base row, which will simply be not 0, it'll be 1. And we want to loop, we want to iterate all the way to the num rows. So for i in range of num rows minus 1, because we've already got the first row. We want to create a temporary array, and that's going to be equal to result minus 1. So result minus 1 is going to be our parent node plus 0 at the beginning and 0 at the end, or 0 at the beginning and 0 at the end. And then we want to create an empty row, and we want to say for j in range, and here is where we're basically doing addition. So we say for j in range length of numbers, or length of result minus 1 plus 1, because we don't want to get an out of bounds error. We will append temp j plus temp j plus 1. And then once we've created our row, we need to append it to our result. So we'll say result.append row. So what we're doing here is for each potential row, we're creating our row, we're adding all the numbers up for our nodes, we're appending the final row to our result, and then we simply need to return our result. So let's run, make sure we've got our code written correctly. Amazing. And now let's submit. Perfect. And we get quite an optimal solution. So yeah, thanks for watching, guys. I'll catch you in the next one.